guys, if you find this video helpful, please like, subscribe and press the bell icon for notifications. Hello guys, in this video we will be reviewing inverse functions. So a function that undo the actions of the original function is the inverse function. So let's take an example with fx is equal 2x plus 3. So the actions for fx are x times 2, that is 2x, then add 3 and we will get 2x plus 3. Now if we want to undo this, then let's take 2x plus 3 as y. Then we will take the opposite actions. So for plus 3, we will take minus 3. And for multiply by 2, we will do divide by 2. So y minus 3 by 2 will be f inverse x. We just need to replace y with x. So f inverse x is x minus 3 by 2. Now let's graph fx and f inverse x. So fx is equals to 2x plus 3 represents a line which will be passing through 0, 3 and minus 3 by 2, 0. So we will get a straight line passing through these 2 points. Now if we take a line y is equals to x and draw a reflection of blue line through this line, then we will get f inverse x. So the reflection of blue line through y is equals to x will be this orange line. So now let's double check it with f inverse x is equal x minus 3 by 2. So if we take 2 points, that is x is equal 0, then we will get minus 3 by 2. For 1 we will get minus 1, and both these points fall on this orange line. So this orange line represents f inverse x. So the reflection of a line through the line y is equals to x will always be a inverse function, or it will always represent f inverse x. So if fx is a function, then f inverse x is f inverse of x or inverse of fx. Both are the same thing. And please note that f inverse x is not same as 1 over fx. It is not a negative exponent. So we cannot say f inverse x is equal 1 over fx. Also, not all functions have an inverse. So there are some conditions for a function to have an inverse, and these conditions are function should be 1-to-1, that is each input, that is x, has a unique output fx. Also it must pass the horizontal line test. So these are the conditions for a function to have an inverse. Now what is 1-to-1 function? So let this be domain x and this is codomain fx. or range fx. Then under transformation f, if we have an input as x, then after going through the transformation we will get fx. Similarly, if we have these three inputs 1, 2, 3 and have an output 4, 5, 6, then the function f 1, 4, 2, 5 and 3, 6 is 1-to-1 function. Now let's take another domain and codomain. So if we have two inputs, that is 1 and 2, and there are three outputs, and these are 3, 4 and 5. 1 will give 5 and 2 will give both 3 and 4. So for 2 it is not a unique output. So input 2 is giving us two different values. So this is not 1-to-1. So this will have an inverse, whereas this will not have an inverse because this is not 1-to-1. Now let's do horizontal line test, and for that let's take a straight line first. So if we take any horizontal line that is passing through this given line, then it will intersect at only one point. So it means this passes the horizontal line test. Whereas for this curve, a horizontal line except this tangent one, all other horizontal line will intersect at two different points. Means horizontal line test does not hold for this curve. So this curve will fail the horizontal line test. So to pass the horizontal line test, it must intersect at most one point. So for inverse, it must be 1-to-1 and must pass the horizontal line test. Now let's find the inverse of a function by taking simple steps. So for that, let's take fx is equal x by 2 minus 4, and then we will try to find its inverse. So in step 1, which is the most important one, that is to check if fx is invertible, and for that we will do the horizontal line test. So we know that this function represents the equation of a line. It is the equation of a line which is passing through 0, minus 4 and 8, 0. And if we will do the horizontal line test, then it will pass the test. Therefore, this function is invertible. Now in step 2, just change fx to y, that is y is equals to fx. So in our original function, fx is equal x by 2 minus 4. Just replace fx with y and we will get y is equal x by 2 minus 4. In step 3, interchange x and y. So replace y with x and x with y, and we will get x is equal y over 2 minus 4. Now in step 4, solve for y, and if we will solve this equation for y, then we will get y is equal 2x plus 8. Now in step 5, change y to f inverse x. So replace y with f inverse x and we will get f inverse x is equals to 2x plus 8. So these are the 5 simple steps to find the inverse of any function fx. Now let's take a trigonometric function fx is equals to sin x, and the graph of sin x will look like this. And if we will do the horizontal line test on this graph, so we can see that it will fail very badly because this horizontal line is intersecting with this curve at more than one point. So for inverse, this must pass the horizontal line test, which this curve didn't. So then how come this function fx is equal sin x still has an inverse? So we will discuss this in our next video.